All right, guys, we're still talking about area and summation, but we're going to talk about something that happens with what we've learned so far. What we have learned to do is not to technically find the area, but to find something called the net signed area. We're going to talk about what that means. So in this little series of videos, so first of all, area we know is a two-dimensional piece of something, and it has a certain size, and that's what we talk about when we mean area. In this case, when we are calculating areas underneath a function, we are taking the sum of boxes that look like this, where we have some delta x and some height of the function. This is the y value at a particular point in the function times a certain delta x, and that gives us an area of a single rectangle, and we add all of those rectangles together to estimate the area. What this is doing, though, because y values, well, we're going to start with y values. First of all, y values can be positive or negative. So if you have a negative y value, for instance, let's say the x-axis is up here, well, then you can't actually have a negative area, but if you're multiplying a negative y times a positive delta x, you're going to get a negative number as the area, even though it's impossible to get a negative area. So that's one of the things we'll see in the coming example. The other, obviously, if the y value is positive y times positive delta x will give you a positive area, so that's not a problem. But there's something else. I have stressed that when you're going, you have your upper and lower bounds for your x values. It's very important that your lower bound actually be less than or equal to your upper bound. That's something I've stressed. So you want to be going from, for instance, well, let's say from 1 to 5, or from 3 to 200. You don't want to be going from 20 to 0, because that's going in the wrong direction. That's not actually how we lay things out. So if you'll notice, if these go to the right, which is the positive direction, but if you had from 20 to 0, what would actually be happening is you'd be going backwards, which is a negative direction. So if you're trying to find, well, we'll get into that in the second half of the video. First, I wanted to give you an example of the kind of thing I'm talking about. So let's actually find something where we will get a negative answer for our area. So let's look at this. Let's do integral from -2 to 1 of 2x dx. We're going to do this. We're actually going to approximate. We're going to use n equals 12 to approximate this. So let's see what's going on here. All right, so as always, the first step is to figure out what delta x is. Okay, so we're going from -2 to 1, which is the normal acceptable thing to do. -2 here, 1. So we're still going in this direction. It's fine. And so we're going to use n is 12. So first we have to figure out what delta x is. So we have 1 minus -2 over 12. 1 minus -2 is 3 divided by 12. That gives us 1/4. So that's our delta x. And notice it's positive. It's fine. And the reason it's positive, again, is because we're going in the correct direction, not backwards. But let's actually see what values this gives us. So I'm going to approximate using the right endpoint estimate. So let's do this one. Would x1 would be 2 plus 1/4, but hold on, -2 plus 1/4. The second one would be -2 plus 2/4, and so on, and we'd get all the points all the way up to 1. So the way to express this would be x sub I. Remember, I is going from 1 to n, which is 12. X sub I, if we're doing this one as our starting point and so on, then what we get is -2 plus I over 4. Okay, so these are our x values that we're going to use to approximate. So we are going to set up the approximation. The approximation is the sum from I equals 1 to 12 of f of -2 plus I over 4 times delta x, which is 1/4. Now this is a constant, so we can bring it out front, and then we have to plug this into the actual function itself, which is 2x. F of x here is 2x. Okay, so this is an approximation for the area, but this is exactly equal to 1/4 times the sum from 1 to 12. I'm not going to write the I every time just because time constraints. Multiply everything in here by 2, and you get -4 plus I over 2. That's what we have. Okay, now I'm going to split this up into the two sums. So 1/4 times the sum from 1 to 12 of -4 plus the sum from I equals 1 to 12 of, I'm actually going to write this as 1/2 I, just because that makes it a little bit more clear that I have a constant here that I can bring out front. But that's what I over 2 is, right? You cut I in half, what you're doing is you're multiplying by a half. So that's what that's doing. And then what is the sum from 1 to 12 of -4? Well, it's -4 times 12. Okay, so let's continue that. So we have 1/4 -4 times 12. That's this first part totally resolved. I used the formula for that. plus 1/4, the constant 1/4 here is still there, times a half, that's this one right here. And then the sum from 1 to 12 of I is the n times n plus 1 over 2. So in other words, 12 times 13 over 2. Now we can simplify this a little bit. I'll give myself some space. Let's go back to red. Okay, so this is what we have so far. We bring this up here. 1/4 of -4, that actually is just -1. So this gives us -12 out front. And then what do we have here? A half of 12 is 6, and half of that is 3. So we have 3 times 13, in other words, 39 over 4. Now this is 1 less than 40. So in other words, this is -12 plus 10 minus 1/4. Okay, so this is all just to get approximation. -12 plus 10 is -2. That's what that is. Minus 1/4. So in other words, we have -2.25. Now looking at the actual graph might help with this. Let's look at the graph of this. Okay, so here's 1, and here's -1 and -2. And then we have 2x, so we're going to need to go down to -4. -4 is down here. And then 1, 2. This one's up here. So we can look at this. Blam. Okay, so our area is this part here, and then this part here is all negative. Dun, 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 dun. Because it's below the x-axis. So remember, each of these y values we plug in are actually negative, so that means that the box that we make with a positive delta x, that's almost impossible to see. So a box we make with a positive delta x and a negative y value is going to give us a negative number inside here. And then this one is going to be positive something, and that makes up for a little bit of it, but not much. And so our final result is a negative number. So, I mean, that's kind of interesting. But again, this is a combination of we're subtracting something and we're adding something on. So it doesn't exactly give us, it doesn't in fact give us either what this area is or what this area is. It adds the two of them together, sort of combines information, and then we only get what the result is. It's like if you had something like -5 plus 19, and you got positive 14 out of that, you wouldn't know which two numbers you had added or subtracted to get this. You just know what the final result is. All right, so we're going to show a little bit more of what this means and how to process this in just a minute.